So now that we know how we can represent a number integer in with two numerals in base 2, we see how we can add two numbers in base 2. So 0 plus 0 is 0, 0 in base 10 and 0 in base 2, 0 plus 1 is 1 in base 10 and 1 in base 2, 1 plus 1 is 2, still 2 in base 10 and 1 0 in base 2, and 1 plus 1 plus 1 equals 3 in base 10 and in base 2 it's 1 1. So on the left hand side we have the carry, and on the right hand side we have the sum. So now if we want to do a 2-bit addition, we actually have 3 inputs. We have A, we have B, and we have the carry in. So let's take an example. So the first carry in will be 0, and let's add those two numbers. So we do like a regular addition: 1 plus 1, 2, 1 plus 1, 2, 1 plus 1 plus 1, 3, 1 plus 1, 2, and 1. So now we can write a truth table for all the 8 possible combination of A and B and carry in, and we can do that for the carry out and the sum. So now you know how to write the truth table. For every time, every row we have 1, then we can write the expression. So that's not A, B, and C, or A, not B, and C, or A, B, and not C, or A, B, C. Sorry, it's cut here. And we can do the same for the sum. So every time we have 1, then we can report the expression. So we have not A, not B, and C. We have not A, B, and not C. We have A, not B, and not C. And we have A, B, C. So and now we can use the property of the boolean algebra to simplify the expression. So that's C times not A, B, or A and not B, or A and B times not C and C. So we can get rid of that. And here by definition you recognize XOR and exclusive OR. So we can simplify this like this. And you can do the same here for the sum. So here we see we have C here, we have C here, so we can factorize by C. So that's C not A and not B, or A and B, and then we can do the same with that not C here, so or not C, and not A and B, or A and not B. You recognize XOR again here on the side. And here we can simplify even more on the left hand side. So that's XOR, XOR B, here, and here. What we can do, we can use the De Morgan theorem, and we can write that this is equals to A, not A or B, the whole thing, or A and B. And here you can use the double negation, it's the same thing. And now we can use De Morgan again to write that this is equal to not A or not B, and this time we can split cut the negation, the first negation. So now all together we can write that this is equal to this, and now we can merge the top negation, so that will make A or B and not A or B, all right, like this. So because we merge to negation, then the or becomes an and here. And now you see that we can simplify even more, that this is A and not A, or A and not B, or B and not A, or B and not B. And now you see that we can simplify those A and not A and those B and not B, because this is false by definition, and so we can get rid of those in the whole expression, and you recognize that we're left here with XOR B by definition. Alright, so altogether we have C and A XOR B, or not C and A XOR B. So what we can do here is write that A XOR B equals, let's call that, oh sorry, there's negation, don't forget the whole negation, still negation of that XOR. So we can write that XOR B equals D, so we're left with C and not D, or not C and D. And you recognize again an exclusive OR on that C and D. So we have, so that's C and not D, or not C and D. So that's C XOR D. So altogether, that's C XOR, and D was XOR B. So that's the expression for the sum. So now we have the expression for the carryout and we have the expression for the sum. So we will be able to build the circuit of binary adder for 2 bits. And if we want more bits, then we put all the adders in cascade. So let's do that. So here we have C out. So we have A, we have B, and we have C. So you see that for C out we need to do C and XOR B, or A and B, and we see that we have XOR B in the sum as well. So we'll start with that XOR B. So remember the schematic sign for XOR B is that kind of crescent with a double bar. So A XOR B there. Now what we can do that A and B here. So we have B there. I can do and there. I can take the A from here. There. So here we have that A and B. And now we can do and C. So XOR B and C. So let's bring that C there. So take this down. So that XOR B and C. And now we'll do the OR between that C and XOR B, or A and B. So we have the A and B, it's there. And we have the C and XOR B, that's there. So that's an OR, sorry, should not be the double bar, it should be only one bar. There's a mistake there. And then we can finish the sum. So the sum we have XOR B, XOR C. So we take that XOR B and we take that C here and put it there. So we have the sum. And this is how we add 2 bits in binary.